Dear students, in this video also we are going to see some more properties of inverse trigonometric functions. In the previous video we have seen some 4 properties of inverse trigonometric function, and further properties are going to see in this video. In the previous video, the 4th property, we have seen that 4th result, cos inverse of minus x equal to pi minus cos inverse of x. I am going to derive this result in the 4th property result. 4th property, 4th result, cos inverse of minus x equal to pi minus cos inverse of x. See, further to prove this result, cos inverse of minus x equal to pi minus cos inverse of x. To prove this result, I am going to consider cos inverse of minus x left hand side by theta. Cos inverse of minus x by theta. From this expression, I get minus x equal to cos theta. Cos inverse of minus x theta implies minus x equal to cos theta. So, multiplying by minus x equal to minus cos theta. You can rewrite this step. Minus x equal to cos theta implies x equal to minus cos theta. But minus cos theta is cos 180 minus theta. The minus cos theta term can be expressed as cos of 180 minus theta. 180 minus theta second quadrant cos negative. Therefore, instead of writing minus cos theta, I can write cos 180 minus theta. So this x equal to cos 180 minus theta. From this, we bring that cos inverse of x equal to pi minus theta. From this expression, we get inverse function cos inverse of x equal to pi minus theta. So cos inverse of x left hand side equal to pi minus theta is my cos of minus x, cos inverse of minus x. So this theta can be replaced by cos inverse of minus x, and you bring this cos inverse of minus x to the left hand side, it becomes cos inverse of minus x equal to pi minus cos inverse of x. That's all about this. Cos inverse of minus x equal to pi minus cos inverse of x. You bring this cos inverse of minus x to the left hand side and minus cos inverse of minus x to the right hand side. We will derive the result. Okay, that's all about the result in the 4th property. Next, 5th property, co-function inverse identities. The 5th properties are called co-function inverse identities. The first property result is sin inverse x plus cos inverse x equal to pi by 2. Sin inverse of x plus cos inverse of x equal to pi by 2, where x belongs to the closed interval minus 1, 1, that you know. Sin inverse of x plus cos inverse of x is 90, pi by 2. For that, to prove this, let us consider sin inverse x by theta. From this, x equal to sin theta. Sin inverse x equal to theta implies x equal to sin theta, taking sin. So, sin theta is nothing but cos 90 minus theta. Cos 90 minus theta is first quadrant. So, cos 90 minus theta is sin theta to know. Therefore, I replace sin theta by cos 90 minus theta. From as usual, cos inverse of x, this cos inverse of x equal to pi by 2 minus theta. And pi by 2 minus this theta we consider sin inverse of x. So, already cos inverse of x in the left hand side. So, cos inverse of x equal to pi by 2 minus sin inverse of x. You bring this minus sin inverse of x to the left hand side, it becomes sin inverse of x plus cos inverse of x equal to pi by 2, which is our correct result. Similarly, the other 2 co-function identities are tan inverse of x plus cot inverse of x is also pi by 2. Cosecant inverse of x plus secant inverse of x is also pi by 2. These are the 3 results under co-function inverse identities. Okay? Next property, 6th one is sin inverse of x plus sin inverse of y equal to sin inverse of x into root of 1 minus y square plus y into root of 1 minus x square, where x square plus y square less than or equal to 1 or xy is less than 0. The 6th property first result is sin inverse of x plus sin inverse of y equal to sin inverse of x into root of 1 minus x square plus y into root of 1 minus x square. For that, to prove this result, let us consider sin inverse of x. You consider sin inverse x by a. So So from this x equal to sin A. You know cos A is root of 1 minus sin square A. So you know cos A, sin A is x. From this cos A is root of 1 minus sin square A. That is root of 1 minus sin A is x, sin square A is x square. So 1 minus x square. So cos A is 1 minus x square, sin A is x. This is sin A and this is cos A. Cos A is root of 1 minus x square. Similarly, we will consider sin inverse of y by b. From this y equal to sin b and root of 1 minus y square equal to cos b. Because root of 1 minus sin square b is cos b. So root of 1 minus sin square b is cos b. So root of 1 minus y square is cos b because sin b is y. So from this idea, I am going to find what is that sin A plus b. Sin of A plus b formula you know. Sin A cos b plus cos A sin b. By trigonometric result, sin A plus b is sin A cos b plus cos A sin b. You know that. Sin A is what? Sin A is x. Cos b is root of 1 minus y square. Plus cos A root of 1 minus x square. Plus cos A is root of 1 minus x square. Into sin b is y. So sin of A plus b equal to x into root of 1 minus x square plus y into root of 1 minus x square. And A plus b is sin inverse of, it becomes sin inverse of x into root of 1 minus y square plus y into root of 1 minus x square. So this is the first result. A, what is A? Sin inverse of x. Plus what is B? Sin inverse of y. So sin inverse of x A, B is sin inverse of y. So A plus B is sin inverse of x plus sin inverse of y equal to sin inverse of x into root of 1 minus y square plus y into root of 1 minus x square. The result is derived. First result is derived. Okay? Similarly, other results, property under 6, some other results are there. Second one is sin inverse of x minus sin inverse of y. This is sin inverse of x minus sin inverse of y equal to sin inverse of x into root of 1 minus y square minus y into root of 1 minus x square. Sin inverse of x minus sin inverse of y equal to sin inverse of x into root of 1 minus y square minus y into root of 1 minus x square. Third one is cos inverse of x plus cos inverse of y equal to cos inverse of xy minus root of 1 minus x square into root of 1 minus y square. Cos inverse of x plus cos inverse of y equal to cos inverse of xy into root of 1 minus x square into root of 1 minus y square. Fourth one, cos inverse of x minus cos inverse of y. Other result is cos inverse of x minus cos inverse of y equal to cos inverse of xy plus root of 1 minus x square into root of 1 minus y square. This is fourth one. Cos inverse of x minus cos inverse of y equal to cos inverse of xy plus root of 1 minus x square into root of 1 minus y square. Fifth one is tan inverse of x plus tan inverse of y equal to tan inverse of x plus y. Tan inverse of x plus tan inverse of y equal to tan inverse of x plus y by 1 minus xy. Sixth one, tan inverse of x minus tan inverse of y equal to tan inverse of x minus y by 1 plus xy. These 6 results are property 6. Okay? Now, the results property in the property 6, the result 2 and 3 are proved as usual as in the case of the result 1. Now I am going to prove the fourth result. Cos inverse of x minus cos inverse of y equal to cos inverse of xy plus root of 1 minus x square into 1 minus x square. For that, to prove this fourth result, as usual, the second and third results are also proved like this only. And you consider cos inverse of x by a, from this x equal to cos a. X equal to cos a, therefore root of 1 minus x square equal to sin a. Okay? Similarly, cos inverse of y equal to b. From this y equal to cos b. Y equal to cos b. So, y equal to cos b. From this root of 1 minus y square is sin b. So using these ideas, the result is cos inverse of x minus cos inverse of y. For that I am going to consider cos of a minus b. The result cos a minus b is cos a cos b plus sin a sin b. You know the result in trigonometry. We have seen cos a minus b is cos a cos b plus sin a sin b. So cos a, you know cos a x, cos a is x, cos b is y plus sin a root of 1 minus x square into sin b root of 1 minus x square. See, from this a minus b equal to cos inverse of the xy plus a root of 1 minus x square into root of 1 minus y square. So what is a? A is cos inverse of x minus b cos inverse of y equal to cos inverse of xy plus root of 1 minus x square into root of 1 minus y square. That's all about the result 4. Okay? Now, in the same property 6, I am going to derive the fifth result. Tan inverse of x plus tan inverse of y equal to tan inverse of x plus y by 1 minus xy. I am going to prove this fifth result. For that, you consider tan inverse of x by a. So this is x equal to tan a. Similarly, tan inverse of y equal to b. From this y equal to tan b. So tan inverse of x, you consider a, x is tan a. Tan inverse of y equal to b, implies y equal to tan b. So you know one formula in trigonometry, tan of a plus b equal to tan a plus tan b by 1 minus tan a tan b. This is the result, you know. Tan a plus b is tan a plus tan b by 1 minus tan a tan b. So you know tan a x, tan b y by 1 minus tan a x tan b y. So x plus y by 1 minus x y. From this, a plus b equal to tan inverse of x plus y by 1 minus xy. What is A? Tan inverse of x. Plus B, tan inverse of y equal to tan inverse of x plus y by 1 minus x. So the result is derived. Tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus xy is derived by using tan inverse of x equal to A and tan inverse of y equal to B. From this two substitution, we will derive the result, fifth one. Like that, the sixth result also you can derive by using the formula tan of A minus B. Tan of A minus B is tan A minus tan B by 1 plus tan A tan B. That you get x minus y by 1 plus xy. This result you will get. The sixth result, as in the case of fifth result, you can derive. Okay? Next, property 7 consisting of 3 results. First result, 2 tan inverse of x equal to tan inverse of 2x by 1 minus x square. And 2 tan inverse of x equal to cos inverse of 1 minus x square by 1 plus x square. And 2 tan inverse of x equal to sin inverse of 2x by 1 plus x square. These 3 results comes under property 7. So first result, 2 tan inverse of x equal to prove the first result, tan inverse of 2x by 1 minus x square. To prove this result, I am considering 2 tan inverse of x equal to theta. From this, tan inverse of x equal to theta by 2. Tan inverse of x equal to theta by 2. You know one half angle formula for tan theta. Tan theta equal to 2 tan theta by 2 by 2 tan theta by 2 by 2 tan theta by 2 by 1 minus tan square theta by 2. This is trigonometric result for tan theta. 2 tan theta by 2 by 1 minus tan square theta by 2. So that is equal to 2 tan theta by 2. 2 into tan theta by 2. What is that? X equal to theta by 2 implies 2 tan theta by 2. See, tan theta, 2 tan theta by 2. Tan theta by 2 is 2 tan inverse of x equal to theta, and tan inverse of x is theta by 2. From this you get x equal to tan theta by 2. X equal to tan theta by 2. So therefore, 2 tan theta by 2 is 2x. Because from this x equal to tan theta by 2. From this 2 tan theta by 2 is 2 into x by 1 minus tan square theta by 2 is x square. 1 minus x square. So tan theta equal to 2x by 1 minus x square. From this theta equal to tan inverse of 2x by 1 minus x square. What is theta? 2 tan inverse of x. And you replace this theta by 2 tan inverse of x equal to tan inverse of 2x by 1 minus x square. That's all about the result. Similarly, second result also I can derive. Second result, to prove the second result, put 2 tan inverse of x as usual. 2 tan inverse of x equal to theta implies tan inverse of x equal to theta by 2. From this you get x equal to tan theta by 2. X equal to tan theta by 2. You know one result for cos theta in terms of tan half angle formula. Cos theta equal to 1 minus tan square theta by 2 by 1 plus tan square theta by 2. This is formula for cos theta. 1 minus tan square theta by 2 by 1 plus tan square theta by 2 in terms of tan theta by 2. So cos theta equal to 1 minus tan theta by 2 is x, 1 minus x square by 1 plus x square. So this theta equal to cos inverse of 1 minus x square by 1 plus x square. Again theta is replaced by 2 tan inverse of x. So 2 tan inverse of x equal to cos inverse of 1 minus x square by 1 plus x square. That's all about the second result. So from the, like that, we derived the property 7. First and third result I derived, second result I derived. You can derive the third result using the sine formula. Sine 2 theta equal to 2 tan theta by 1 plus tan square theta by 2 formula. You apply, you will get the second result, third result. For sine 2 theta in terms of tan, 2 tan theta by 1 plus tan square theta by 2. That will give you the third result. That's all about the property 7. I will stop my video here and we will continue in the remaining in the next video. Thank you.